So 21.5 scale factor. When we're looking at scale factor, the way that we look at that, I call the ratios R. R for just a linear, if we're just comparing the length of sides or comparing the radius, anything that's linear we can compare. And then R squared would be something that deals with area, because the units are squared. And then R cubed would be something that deals with cubic, because it's cubed. So similar solids are solids that have two solids that have equal ratios when you're comparing their corresponding linear measures. So in this example, if we compared their linear measures, and let's say that this is our image and this is our pre-image. So if we're looking for a scale factor, remember it's always the new or the image over the pre-image. So if I just compared the sides, the linear parts, I can compare 2 over 4. Does that equal 3 over 6? And does that equal 5 over 10? If those are all equal, then the figures obviously would be similar, and it would give us the scale factor. So this gives me 1/2, this gives me 1/2, this gives me 1/2. The scale factor is 1/2. So when we look at the scale factor, it's the common ratio of linear measures for a pair of solids. So in this example, 1/2 is the scale factor. Now remember, in this case, this is a reduction. Just a quick review. And to calculate that, we always take the image and divide it by the pre-image. It tells you what you started with and what you're ending up with. If we started with this figure, then this is a smaller figure, so it would be a reduction. If we went the other way and I said this is our pre-image and this is our image, then it would have been an enlargement. So paying attention to if it tells you whether it's an image, whether you have a pre-image or an image, that helps you with determining whether it is a reduction or enlargement. Alright, so if two solids are similar, meaning their scale factors are the same with all corresponding side lengths having the same ratio, we are looking at a linear comparison. So we're doing a linear comparison written as a ratio. The example above, R would be equal to 1/2. That ratio would be 1/2. When we're looking at R squared, we're looking at an area ratio. R squared would be taking your R and squaring it. So taking the 1/2 and squaring it, it would give us 1/4. And what do you think R cubed is? What kind of ratio would that be? Somebody tell me out loud. What do you think it is? Volume. Good. So it's a volume ratio. So if you think of the units, that helps you. Linear units are just units to the first power. We don't usually write that. We just write units. So R to the first power. Area, the units are squared, so R squared. Volume, the units are cubed, so R cubed. So if we took our R and we said let's take that and cube it, then that would give us 1/2 to the third power, which gives us 1/8. If we were to actually take one of the side lengths and square it and compare those, that ratio would come down to 1/4. If we found the volume of each of these and we compared them, that ratio would come out to 1/8 once we reduced it. So let's look at this example. This example, number 1, says if two pyramids have a side ratio 3:2, that's telling me, because it's a side ratio, that's telling me we're comparing, and we're getting a ratio that's represented by R. And notice the 3 is bigger, so we're comparing large to small. So we're comparing large to small. Here it says find the ratio of their surface areas. Now their surface areas, we're talking about area. So for surface areas, we're talking about R squared. And for their volumes, we're talking about R cubed. So as I look at this, because it's larger to small, the large is my image, and the small is my pre-image. Kind of just thinking about the order of things. And it says to find the ratio of their surface areas and volumes. Now we don't have to calculate what the volume is and what the area is of any of the side lengths. We can figure those out. And we can figure out what the surface area ratio would be without finding the area of the base and then comparing them and then reducing it. Or finding the volume of this and then finding the volume of this and reducing them. We can use the scale factors to get those ratios. And so the key word here is ratio. It doesn't say you have to find the actual surface area. It doesn't say you have to find the actual volumes. It says to find the ratio. So to do this, we're going to take R and we're going to go to R squared. And so we're going to think about how can we go from R to R squared, where R is 3 over 2. And if we want to go to R squared, we're going to take that 3 halves and we're going to square it. And when I square that, I square the numerator and I square the denominator. And so 3 squared gives me 9 and 2 squared gives me 4. And this is the ratio of the surface areas. Now, to get the ratio of the volumes, we're going to take the R and we want to find what is R squared, or R cubed. So we need to find R cubed. So R is 3 halves, and we're going to take that R of 3 halves and we're going to cube it. So 3 cubed is 3 times 3 times 3, which is 27, and 2 cubed is 2 times 2 times 2, which is 8. And so now we have the ratio of volumes. So again, we didn't have to find the volume of each to figure it out. We just had to take the scale factor that was given and then square it or cube it. All right, let's try a couple of examples. So looking at this cone, this has a radius of 4 and a height of 6, a radius of 6 and a height of 9. Now, to find, it says decide whether the solids are similar, and then find the scale factor. So if they're similar, the ratios of each should be the same. So if I take 4, I'm going to compare it to 6. And if I started with the smaller and went to the larger, I'm going to start with the smaller height and compare it to the larger height. So is this true? So is 4 6 equal to 6 ninths? A couple ways you can do it. You can reduce them. You have your choice. You can reduce. And when I reduce, this gives me 2/3, and this gives me 2/3. So the answer is yes. The other way that you can do it is you can take this and say, well, I'm just going to cross multiply, and I get 36 equals 36. So you can do either of these, and it does show you that they're equivalent. And so the answer for this is yes, they are similar, and the scale factor is equal to 2/3. So there's our answer. Yes, they are similar, and the scale factor is 2/3. Alright, let's take a look at part B. Figure that one out on your own. Determine if they're similar, and if they are, what is the scale factor? And I'm going to do it quickly, and you should do it as well. Okay, so no, the solids are not similar. Notice I didn't even need to look. If you only check 2 of them, you would get 4/5 equals 4/5. But you need to check all of them. Okay, so check all of them. Alright, decide whether these are similar. If so, find the scale factor. So I'm going to choose one of these to do, and I think the one I'm going to choose to do is this one right here. The answers for the other 2 are no, and the answer here is yes, and the scale factor here is going to equal 2/3, and the answer here is no, and you can do the work. But let's do number 3 because we're not going to do everything. So number 3, I look at this, and it doesn't tell me which is, so your answer, you can have 2 possible answers because it doesn't tell you which is the bigger and which is the smaller. It just depends on which way you look at it. Now, these are going 2 different directions, so you need to realize that which sides correspond to which sides. So I'm going to say 3/1, 3/1, and 12/4. Now, maybe you said 1/3, 1/3, and 4/12. That's fine because it doesn't tell you which order. Okay. So it looks like these all give me 3/1, or 3:1. So the answer is yes, they are similar. And your scale factor is 3/1. Again, for this one, if you wrote the scale factor was 1/3, I would take that as well because it doesn't tell you to pay attention to the order. Okay, I'm going to flip it over. We have some more examples that I want to go through. And whatever I don't go through, I'll take a picture of and I will put on Google Classroom so you can look back at. Alright, so looking at these, if it says to determine if these are linear or similar or not, this one the answer is going to be no, and this one the answer is going to be yes. And then what is the scale factor? 2/3. Actually, I'm going to write the word scale factor out for this one. Okay. I didn't want to do another couple of examples with you because I don't think we need to do all of those. But let's look at this one here. It says, what is the ratio of the height of the larger to the height of the smaller? So here, the order is important because it's telling you. You are listing larger to smaller. So large to small. And so this one is one I want you to pay close attention to because this one is a little more difficult than those first ones. So if I look at the larger to the smaller, the larger I'm given the radius and a radius and a height and a height. So I can say that 21/7, which reduces down to 3/1. And I also could have said 12/4, which reduces to 3:1. So my answer is 3:1. It says, oops, I was doing this out of order. This says the height. I wasn't to put that there. Okay, looking back and reading it a little bit closer, it says the ratio of the height. The next sentence says the ratio of the radius. Again, large to small. So what I had put here, I need to put down here 12/4. 4, which again gives me 3 to 1. So what we're doing is kind of working through finding the scale factors. So the ratio of the circumference of the bases. We actually don't have to calculate the circumference. We can figure it out. If you want to calculate it, you can. So I think we will to prove a point here. So for part C, I don't have quite enough room up there to do it, but if we do the ratio of the circumference of the bases, the circumference of the large over the circumference of the small, the large would be 2 pi 12, and the small would be 2 pi 4. And then you can see that the 2 pi cancels, and it just leaves us with 3 over 1, which gives us our value for r. So the ratio of the circumference of the bases is 3 over 1. Same as what we got here because we were comparing linear parts. The circumference is like taking a measuring tape and wrapping it around a circle. If you straighten that measuring tape out, you can see it's linear. The next one says to find the base area of the cylinders. So here we were talking about linear. Here we're talking about base area. So for part D, the large area and the small area. So the large area would be pi times 12 squared, and the small area would be pi times 4 squared. Well, we can immediately see that the pi cancels, and then 12 squared and 4 squared give us 144 over 16. And does 144 and 16, can we reduce that? Well, let's just see. Does 144 divide, does 9 divide into 140? Does 16 divide into 144? And it does. It divides into it 9 times. So this gives me 9 over 1. So I want you to think about how that relates back to this. That is the same thing as 3 over 1 squared. So this gives me my r squared. So my base area is 9 over 1, and again that was our r squared. So we got our r on part B, we got our r squared on part D, and part E says the ratio of the cylinders. So the ratio of the cylinders, what do we think that's going to look like? I'm thinking that to find E, here's what I think we're going to get. I think the volume of the large over the volume of the small, I think it will be whatever that 3 over 1 is that we started with up here. I think it's going to be 3 over 1 cubed. So I think it's going to be 3 over 1 cubed, which means that I'm going to get 3 cubed giving me 27, 1 cubed giving me 1. So I think that's what I'm going to get, but let's prove it. Let's do a proof. The volume of the large would be pi 12 squared times the height of 21. The volume of the small would be pi 4 squared times the height, which is 7. I can cancel out the pi's. I can see that 21 and 7 gives me 1 and 3. And so now when I multiply 12 squared times 3, that's going to give me 432 And when I take 4 and I square it, that gives me 16. I'm thinking that it will give me 27 over 1. But let's just double check and see if I take 432 and I divide it by 16, it does give me 27 over 1, which is the same thing. And that is what I expected, to get 27 over 1, which gives me r cubed. So this little bit of a proof and example that we did, we don't have to go back and find the area, the circumference. We don't have to find the area. We don't have to find the volume. To understand that the relationship between these scale factors, if we have a linear ratio, we can square it to get the ratio of the areas. If we have a linear ratio, we can cube it to get the ratio of the volumes. And so here are 3 examples. We're going to do these and then we'll be done. I know this is a little bit long, but these last 3 are really important to pull everything together. This one says, if the volume of 2 solids are this and this, find the scale factor large to small. Now I knew it was large to small because, well, this is our large, this is our small, so we can figure that out. So what I want to do is I want to look at this and recognize that when we're talking about volume, we're talking about r cubed, okay? 2 similar solids. Now you need to know, how do I use my calculator to find the cube root? Because what we want, it says find the scale factor. So what we want to do is we want to find r. So we're going to take r cubed and we want to find r. So how do we do that? You're going to use your calculator and you're going to take the cube root of r cubed, and that will give you r. Now r is going to be some value. It's not just going to be r, it'll be some value. So let's first start with the ratio of the volumes. We need to find that. Because they gave us the volumes, we're going to take that and we're going to find the ratio. And so 2,304 over 972. So these are not perfect squares or perfect cubes. So let me write some perfect cubes down just to kind of get you thinking. So up here in my corner, I'm going to write cubes. And some perfect cubes are 1, because 1 cubed is 1. 2 cubed is 8. 3 cubed is 3 times 3 times 3, which is 27. 4 cubed, 4 times 4 times 4 is 64. 5 cubed, 5 times 5 times 5, 125. 6 cubed, 6 times 6 times 6, 216. 7 cubed, 7 times 7 times 7, 343. 8 cubed, 8 times 8, 64 times 8, 512. 9 cubed, 9 times 9, 81 times 9, 729. And then 10 cubed, 1,000. Now, do I have all these memorized? No. I was able to tell you them so quickly because I have them written down. So no, I don't have these memorized. Squares I have memorized. Cubes, not all of them. I have up to about right here memorized. Alright, so perfect cubes. So these are not, you can try these and see, are they perfect cubes? To find the cube root. The cube root on my calculator. Some of yours has a cube root. Like here's a square root on mine. Let me zoom in on my calculator. So on my calculator, there's my square root. I don't have a cube root, but I have this one that has an x and a radical. And that's the one I'm going to use for cube root. Some of you have cube root, which is great. It makes it a lot easier. But let's do one to make sure everybody knows. The cube root of 27 is 3. So let's practice that in our calculator to make sure that you know how to use that. So for my calculator, I have to tell the calculator that my index is 3, meaning I'm taking the third root. and then I'm going to second and hit that key right there. So now that calculator recognizes that this value for x is 3. And if I hit 27 in my head, I already know the answer should be 3. And it is. So we're testing it out with something that we know. Everyone should be trying this on their calculator. I don't want you to leave from this lesson and say, I don't know how to use my calculator. Okay? Let's try one more. We know that the cube root of 512, the cube root of 512 is going to be 8, because 8 cubed gives me 512. So let's try that one. I need to tell my calculator I'm taking the cube root, or the third root. There's my radical that says I'm taking the cube root of 512, and I expect my answer to be 8, and it is. So hopefully you're practicing this with your calculator, so when you go to do your assignment, you can use your calculator correctly. This is a math class, so everyone should have that. Alright, so here, these are not perfect cubes. We can try it. We can say, let's take the cube root of 2304. And it's not a perfect cube. It gives me a decimal. But these are both even, so I know I can reduce them. And when I reduce these, it reduces. And it's going to reduce down to 192 over 81. Okay, so we're trying to take the cube root. 192 is not a perfect cube. I could have reduced that more. I just divided it by 2 because I saw they were evens, and I wasn't thinking, okay, what else can go in there? I can reduce this some more. What else could I divide this by? 3. So if I reduce it and divide it by 3, it gives me 64 over 27. Now, maybe you saw just divide the whole thing by 6 on the top and by 6 on the bottom. But if you don't see that, just start with 2 because the numbers are even. Okay? So now we have cubes. So now we have cubes. Now we can take the cube root to find the scale factor. So take the cube root to find r. So we're taking the cube root of r, which in this case it's the cube root of 64 over 27. I'm sorry, the cube root of r cubed. And it will give us r. So I'm going to take this. And so we had 64. And we had 27. And when I take the cube root of 64, you get 4. And when I take the cube root of 27, I get 3. This here is my value for r. It is my scale factor. Another way to look at it, it is r. Okay, we're going to skip number 7. I will put that in your notes, and let's just jump down to number 8. So number 8, here it says, if the volume of two similar solids is this, find the scale factor small to large. I feel like we just did that one. Okay, let's go back and do number 7, because I feel like this is the same as what we did up here, right? Volume of two solids, find the scale factor. 8 and 7 are alike. So let's do 7. 8 and 6 are alike. So let's do 7. 7 tells us that the area of the base, so here they're giving us area. So area is going to be our r squared. Find the scale factor, and the scale factor is r. Then find the ratio of the volumes, and that's going to be r cubed. So this one has us do 3 things. So the first thing we're going to start out with is they're telling us we want to find the left, so the scale factor of left to right. So in this case, it's small to large. That's important because you want the order. So r squared is given to us 154 over 2,464. We eventually want to be able to get to r and then find r cubed. Notice I don't have any other information other than the base area, so I don't need the height, I don't have to calculate the actual volumes, but what I do need to do, are these perfect squares? No. So what do you have to do first before you can try to take the square root? Right, you want to simplify, you want to reduce. And so when it reduces, the first thing I would do is see if this top number, the numerator, divides evenly into the denominator. Does it? It does? How many times? 16. So it reduces down to 1/16. Okay? So now we can take that r squared and we say that it's equal to 1/16, and we can take the square root of it to give us r. So we're going to take the square root of 1/16. Think of it as the square root of 1 over the square root of 16. Okay? Square root of 1 is 1. Square root of 16, 4. So that gives us our scale factor is equal to 1/4. That is our r. Okay, so our r is equal to 1/4. Now we want to find, so we've done the scale factor, we've done this part here. Now we want to find the ratio of the volumes. So that means we're going to take r and we want to find r cubed. So we take this ratio, which is 1/4, and we're going to cube it. And what do we get when we cube it? Well, 1 cubed is 1. 4 cubed is 4 times 4 times 4, 64. So the ratio of the volumes is equal to 1/64. That is our r cubed. Now the only thing that was given to us was that the area, this area, doesn't matter which one, but the area of the base was given to be 154 inches squared, and the area over here was given to be 2,464 inches squared. So that was the only thing we were given, and from that we could determine that the ratio of the volume was 1/64, and the scale factor was 1/4. And that is it. I'm going to show you on my screen the last problem in case you want to take a screenshot of it and look back on it and review it. You can. Okay. We are done, so you can go ahead and go back to working on the rest of your assignments. And let me pause for just a second.